All right, just a little warning here, just to let you guys know what's going on and stuff. If you come over here and get on your Webwork, remember, your pre-section videos are automatically going to be start closing down and stuff like that. Today, we're going to be doing, a big part of it is going to be section 5.4 for today. I hope to jump into section 5.5, but if you look at your Webwork stuff, because, I mean, we've been in class for a while now, but they just ended up drop add. So all of a sudden, these things are going to start closing out on you guys. So you got to make sure that you get done by the 22nd. The review, section 5.1, 5.2, 5.3, which is what we covered last time. If you notice on these particular sites, I always try to make the Webwork due on a particular weekend. So you at least have the Friday at our review session, so if you got questions, you can come by and ask. So today is going to be our first review session, so it's at 2 o'clock over in Fretwell 113, so don't forget. All right. Last time, we were finishing up that section 5.3, and we were working on some physics Webwork problems, but I had 2 more problems to do before we get into our next section. I want to make sure I cover those things for you guys. And here is one of them. So this is from section 5.3. It says this: acceleration function for a particle moving along a line is a of t equals 2t plus 3. The initial velocity is v of 0 equals negative 10. You're supposed to, part A, find the velocity at time t, v of t, a formula, and then look at the next question. You were supposed to find the distance traveled during the time interval between 0 and 4 seconds, or whatever it happens to be, and is equal to what? All right, first things first. You should know this. When I integrate acceleration, what am I going to get? Velocity. And when I integrate velocity, what am I going to get? Position. We're going in reverse. So the integral of acceleration is the velocity function. The integral of velocity function is the position function, typically denoted as an S of t here. So if they want a velocity function, what I'm going to do here is I'm going to get velocity, I'm going to integrate the acceleration, which was given to be 2t plus 3 dt. Well, 2 is a constant. Leave alone integral of t. T to the first power is t squared over 2, plus integral of t, 3 with respect to t is 3t. And of course, this is an improper integral, so you've got a big O plus c. This cancels here, so you're left with v of t is equal to t squared plus 3t plus c. But you got to figure out what the c is. And if you remember your section 4.9 calculus 1 stuff, you find that c by initial condition. The initial condition they gave me was the fact that v of 0 equals negative 10. So when I plug in negative 10, when I plug in 0 in for time, that'll be 0 squared plus 3 times 0 plus c, and that's going to be equal to negative 10. Well, that's 0 and that's 0, making c equal to negative 10. Therefore, the velocity equation is equal to t squared plus 3t minus 10. There's my velocity equation. There's the answer for part A. But now, look at the next question. The next question is, the distance traveled during the time interval between 0 and 4 seconds is equal to what? This is talking about total distance. Total distance. If I use the word displacement, the formula is just integrate velocity over your bounds, and you want the negatives to cancel with the positives. But when they ask for total distance, what you want to do here is total distance is equal to the integral from A to B of the absolute value of your velocity function. This was a formula we went over last time. But how do I integrate an absolute value? You don't. What you're going to do here is you're going to take this particular graph, the velocity equation, t squared plus 3t minus 10, and graph him. But all you care about is between 0 and 4. And when you graph this thing between 0 and 4, I'm just going to graph it for you, it's a parabola, but when I plug in 2, I get 0, so it goes through this point. Down here, when t is 0, it's negative 10. So it looks like this. Now, when you look at this thing, very important. Between 0 and 2, the area is negative, and between 2 and 4, the area is positive. But for that distance, we don't want the negatives to cancel with the positives. So this is telling me what I need to break up my integral over. So this would be equal to the integral between 0 and 2 of my velocity function, t squared minus 3t minus 10 dt. But when I integrate from 0 to 2, what kind of answer am I going to get? Being it's below the x-axis, what kind of area, what kind of answer? It's negative, so you really want the absolute value to show up here. And then I'm going to add the integral between 2 and 4 of t squared minus 3t, plus 3t minus 10 dt. What kind of answer will I get when I integrate t squared plus 3t minus 10 between 2 and 4? Well, the region is captured above the x-axis. That's positive. You can put some absolute values around this guy, but honestly, those absolute values aren't going to mean anything because the answer is going to be positive for there. Does that make sense? And this is how you get your answer. So here we go. Integrating this guy here, well, no problems here. Integral of t squared is t cubed over 3, plus integral of 3t is 3t squared over 2. Integral of minus 10 is minus 10t, evaluated from 0 to 2. And remember, it's going to be absolute value, plus, I integrate them again, same function, 3t over 3 plus 3t squared over 2 minus 10t, evaluated from 2 to 4. Fundamental theorem of calculus, you plug in top minus plug in bottom. So this is going to be equal to, plug in top, 2 cubed over 3 plus 3 times 2 squared over 2 minus 10 times 2. Minus when I plug in 0. I love plugging 0 in things. Typically it's going to be 0. And then that's going to be a negative, so I'm going to do the absolute value of that guy. Plus, plug in top, that'll be 4 cubed over 3 plus 3 times 4 squared over 2 minus 10 times 4. Minus plug in bottom, 2 cubed over 3 plus 3 times 2 squared over 2 minus 10 times 2. This is already going to be positive. Sticking absolute value is not going to matter here. So when I crunch this thing out here, I end up getting negative 11.33333, but it's absolute value. Plus the absolute value of this thing I get over here when I plug in 4. Let me just show you this. Plugging a 4 on this thing, it's 4 cubed, just 4 cubed divided by 3. Oh, come on now, quit, second quit, clear. 4 cubed over arrow divided by 3 plus 3 times 4 squared divided by 2 minus 10 times 4. When I plug that in, I end up getting, I'll put it over here so you can see it, 5.33333 minus, when I plug this number in, I get a negative 11.33333. So what is my answer going to be? Well, absolute value of a negative 11.33333 is 11.33333 plus 5.333. A negative, a minus makes it plus another 11.33333. I end up getting, pretty much when you add it up in decimals, it's 28. The answer is 28. And I didn't put units on this thing, but if I did, it would be a distance, so 28 feet, 28 meters, 28 miles, 28 kilometers, whatever it happens to be, 28. But the trick is, you got to break over your negative regions from positive regions and absolute value of the negative region so you can get total distance or total area. That's the trick on total versus displacement. All right, this next one. This is using the concepts of the integral. All right, and remember, when I integrate a derivative, that gives me the original function back up to a constant plus c. So when I integrate the second derivative, what do you think I'm going to get? The first derivative plus c. So here's the deal. Now this was actually a pretty easy problem, but it's information overload is what messes people up. It says this: suppose h is a function such that h of 1 equals negative 8, h prime of 1 equals 2, h double prime of 1 equals 7, h of 10 equals 4, h prime of 10 equals negative 10, and h double prime of 10 equals 17. H double prime is a continuous function everywhere. Then what would the integral between 1 and 10 of h double prime of u du be? Well, as long as this variable and that variable matches up, I'm just integrating h double prime. And so the integral between 1 and 10 of h double prime of u du would officially be integrating a second derivative gives you a first derivative of u evaluated from 1 to 10. Okay. Integrating a second derivative gives you the first derivative. That's one of our properties. Now, according to the fundamental theorem of calculus, what am I going to do? Plug in top, h prime of 10 minus plug in bottom, h prime of 1. So they gave me all this stuff, but all I really need is to know what h prime of 10 is. H prime of 10 is negative 10 minus h prime of 1 is 2, and the answer is negative 12. See, all that other stuff I didn't actually need, because all I needed to know to integrate a second derivative is the first derivative. And since you got bounds, fundamental theorem, plug in top minus plug in bottom. Now, section 5.4 is more on this concept of fundamental theorem of calculus. And hopefully you watched the awesome pre-section video where I introduced this idea. This idea is basically about taking the derivative of an integral. And since the integral is the antiderivative, derivatives and antiderivatives are going to cancel. So that's kind of what I did with this stuff. And the last little part, we talked about a special formula that you'll need to have to memorize, which is that average value. So we'll talk about that in just a second. In terms of the algebra review you need to know about in this particular stuff, here's your algebra review. First off, you know about the derivative of a chain rule, f of g of x is the chain rule. Derivative outside, inside stays the same time derivative inside. So that's derivative of f of g of x is f prime of g of x times g prime of x. So when you're taking the derivative of e to the x squared, calculus 1 at its best, this is the e to a function, so derivative of e to a function is e to a function times derivative of the exponent. So the answer is going to be e to the x squared times derivative of the exponent, which is 2x. And if I ask you to take derivative of the natural log of x quantity to the fourth, the inside is the natural log of x, the outside is the fourth. So the derivative would be, take derivative of the outside, derivative of the fourth part is 4, inside stays the same, natural log of x cubed times derivative of the inside. And what's derivative of natural log of x? 1 over x. Okay? The other thing you're going to need for this particular section is the ability to solve for a variable. And don't throw it off because I have multiple variables here. Let's take a look at this thing. Z squared minus 6x to the negative fourth equals 3 plus z squared. Your mission is to solve for x. To solve for x, I want to get the x by himself. There's only one term with x in it, and granted it's x to the negative fourth, but what I'm going to do here is subtract the z squared from both sides. And notice what happens. They completely cancel on both sides, leaving you with negative 6x to the negative fourth equals 3. I'm going to clean this guy up. This is negative 6 over x to the fourth. Negative exponent goes on the bottom equals 3. Solving for x, I don't like fractions. Solving for anything, I don't like fractions. I'm going to multiply by x to the fourth, common denominator on both sides. That gives me negative 6, here it cancels, equals 3x to the fourth. I'm going to divide by 3 on both sides. This cancels, and end up getting x to the fourth is equal to negative 2. Now what have I got to do? Take the fourth root of both sides, and being an even root, you take plus or minus the fourth root. But the fact is, you're taking the fourth root of a negative number, so what is my answer? Does not exist. If this was a positive 2, then the answer would be either plus or minus the fourth root of 2. I'm just trying to remind you about how to do some basic algebra. Just because they have some extra variables on this thing, well, leave them as constants, but in certain cases, when you move them around, maybe they completely cancel out or something or other. In this case, they did. Now, here's the idea behind the fundamental theorem of calculus. This is a very short section because section 5.5 is actually our long section. Here's the idea. if f is a continuous function on the interval between a and b, and g of x is equal to the integral from a up to some arbitrary x of some function f of t dt, where a is less than or equal to x, which is less than or equal to b, then the derivative of g prime of x, would actually be equal to f of x. Because, here's the thing, I would have to integrate this guy. So if you actually look at the algebra on this thing, g of x would be equal to, what is the antiderivative of little f of x? It's going to be big, or little f of t, will be big f of t evaluated from a to x. So when you clean that up, this means g of x is equal to big f of x minus big f of a. But that's not the question. The question is, what is g prime? So to now take the derivative of it, g prime of x would be equal to f prime of x minus, what is f prime of a? This is the important part. A is a constant. You plug a constant in a function, you can get some crappy constant. What is the derivative of a crappy constant? 0. So that a won't even show up because its derivative will be 0. So, and the derivative of big f of x is little f of x, and that's what they're stating here. That's the idea behind it. So, this is supposed to be pay attention and catch patterns in mathematics. So, instead of doing all this work, if I'm trying to take the derivative of an integral of f of t dt evaluated from a to x, it's the derivative and the integral are going to cancel, and you're just going to left with the function f of t and just plug an x into it. You end up getting just f of x. You don't have to do all this work. There's a pattern to it. The derivative and the integral will cancel, and you're left with the function evaluated at x. And that's what we're stating here. In terms of our Leibniz notation, the derivative with respect to x of the integral from a to x, notice the x is the variable on the top here, of f of t dt, the derivative and the integral cancel, and you're left with f of x. That's what this theorem is telling you up here. But there's more to it. What if we have something other than x? Well, here's our first rule right here. The derivative of an integral from a to x of f of t dt, the derivative integral cancel, you're left with just that function in terms of x. But what if the variable is on the lower bound, the integral from the integral from x up to a of f of t dt? Well, here's the deal. That fundamental theorem about plug in top minus plug in bottom, because the variable is on the bottom, you're going to have minus f of x. It's because the variable is on the bottom is where the negative is coming from. But here, when I take the derivative of an integral from a up to, this is not x, but a function of x, of f of t dt. The derivative and integral will cancel, so you're just going to be left with f with the g of x function, whatever that function is plugged in for t. But because you are taking the derivative, you got to do the chain rule, times the derivative of what you plugged in. See, I'm using chain rule here, but the derivative of x is 1, so that derivative of the inside stuff never shows up when you just use x. But anything other than x, you got to do times the derivative of the inside. So you get your last one, which makes it a little more complicated, and that is the derivative of the integral from some function h of x to the other function g of x of f of t dt. The derivative and the integral cancel, so you plug in top into the f function, times the derivative of what you plugged in, minus plug in the bottom into your function, times the derivative of what you plugged in. This is called the fundamental theorem of calculus. And in English, when there are two fundamental theorem of calculuses, let me explain. This is the, quote, first fundamental theorem of calculus, according to Dr. Stewart, our author of our textbook. And the derivative and the integral cancel. That's what we're going on. The other fundamental theorem of calculus, which we've already introduced to you guys, is when you integrate with bounds, you take the antiderivative and you plug in top minus plug in bottom. Dr. Stewart calls that the fundamental theorem of calculus part 2, or the second part. I can't remember which one's part 1, part 2. So in my directions on any kind of test, I will say use one of the fundamental theorems of calculus to solve this thing here. And whether you're taking the derivative of an integral or you're just evaluating some integral over bounds. So let's take a look at these problems here. So here we go. Here's the way you're supposed to do it. And then I'm going to let you know the way people like to do it, or the hard way. Here's the deal. The derivative of the integral from 3 to x of cosine of t dt. Well, the derivative and the integral are going to cancel. X is on the top. The answer is going to be cosine of x. And you're done. It is a 10-second question. Even if 10 seconds may be a little long for you guys on this one. But a lot of people are hard-headed in my classes, so they're going to make me do it the long way. All right, fine. This one I can. Do it the long way. The derivative of the integral from 3 to x of the cosine of t dt is this. What is the integral of cosine? Sine of t, evaluated from 3 to x, and then eventually we're going to take derivative of it. I'm working inside the parentheses first. So I actually did that. I integrated cosine, and I get sine t. According to the fundamental theorem of calculus, we plug in top minus plug in bottom. So this would be the derivative of plug in top, the sine of x minus plug in bottom, the sine of 3. Now, take its derivative. What's the derivative of sine of x? Calc 1 at its best. Cosine of x minus, what's the derivative of sine of 3? Just want to show you guys. Notice what mode I'm in on the calculator. I'm in radian mode. The sine of 3 is 0.14112000081. What is the derivative of 0.14112000081? Being a constant, it is 0. And so what is my answer? Cosine of x. And that's just great because, yeah, it's the same answer. But here's my point. The key to math is catch a pattern. I didn't have to jump through all these hoops to actually get the answer because we know the fundamental theorem of calculus. The derivative and the integral are going to cancel. You're just going to get the function back again with the x value, if it's on the top bound, plugged in for the whatever variable they're playing with in terms of the integral. So take a look at this guy here. The derivative of the 107x of 1 plus the square root of 9 minus t squared dt equals, well, the derivative integral cancels, and x is on the top, so the answer is going to be 1 plus the square root of 9 minus x squared. That's it. The point I'm trying to make to you guys is, yes, I'm taking derivative of integral. Did I actually integrate anybody? No, not really. Did I take derivative of anybody? No, pretty much not. All I do is they're going to cancel each other out, and I'm left with the function. Well, what happened to the 107? Well, it's a constant, so when you do integrate and then plug in the constant and then take its derivative constant is 0. So that 107 never shows up. I just made up some numbers and chucked on the bound. 107 sounded good to me. So, look at this one. The derivative with respect to y of the integral from 107 to y of x cubed plus x squared minus 4x over the cosine of x plus 12 dx. Well, all I did on this one was change my variable. What's my variable of interest in this problem? We're taking the derivative with respect to y. I'm focused on y's only, and there's a y on the top bound. So what's the answer? Well, the derivative and integral cancel. Y is on top, so the answer is going to be y cubed plus y squared minus 4y divided by the cosine of y plus 12. What happened to 107? That's a constant. It eventually died off anyway. Does that make sense? Now, help me out. Do the next one. The derivative with respect to x of the integral from x to 4 of tangent of t plus the secant squared of t plus e to the cosine t dt. Now, I'm trying to make this as simple as possible because it is a simple concept. But some students just want to make everything hard. They actually want to integrate this stuff. Then they want to take its derivative. And I'll come back in about 20 years and see how they're doing on this stuff. This is not really what we're after here. We're after the concept of derivatives and integrals are opposite. They cancel. The big deal on this one is the variable is on the bottom. And because the variable is on the bottom, what's the big deal? Minus parentheses, minus the entire function. And the function is going to be the tangent evaluated at that variable x plus secant squared evaluated at that variable x plus e to the cosine of x. That's it. No plus c's, no anything like that, no bounds, just the function itself. The derivative integral cancel, you get the function with the variable in it. But because the variable is on the bottom integrand, you're going to have negative that function. You can distribute the negative on Webwork if you want to, but we're happy with you just giving negative parenthesis on that thing. Now the next one is the derivative with respect to x of the integral from 5 to x squared of the square root of t squared plus 14t dt. Well, again, the derivative and the integral cancel, but I notice I don't have just x. I have anything other than x. I have a function of x, x squared. So this is going to be the chain rule version of this fundamental theorem of calculus. The chain rule version is basically the derivative integral cancel. You replace the variable with this function, x squared, but then parentheses around it times the derivative of the inside. Chain rule, times derivative of the inside. So the answer is going to be the square root of x squared. Now the t is being squared, so it's x squared squared plus 14 times x squared. Notice I literally replaced the t's with x squareds on this thing. And then chain rule times the derivative of the inside. What's the derivative of x squared? 2x. Now, of course, you probably want to clean this up, make it look good. So this would be 2x times the square root of x to the fourth plus 14x squared. That's absolutely fine. But there's my answer. The chain rule version of the fundamental theorem of calculus. Similar, take the derivative with respect to x of the integral of x squared to the sine of x of the square root of t plus 5 dt. Well, again, the derivative and the integral are going to cancel, but this time I notice I have a function of x, because we're taking derivative with respect to x, a function of x on my top integrand, and I got a function of x on my bottom integrand. So this is that plug in top minus plug in bottom. So this is going to be the square root of plug in the top. That would replace x with sine of x, replace t with sine of x, plus 5. Chain rule times derivative of the inside. What's derivative of sine of x? Cosine of x. Minus plug in bottom. The square root of x squared plus 5 times derivative of what you plugged in for that guy, which is 2x. And there's my answer. My point is, am I doing a lot of work on this stuff? No, not really, because I understand how things connect to each other. The derivative and integrals cancel. That's the goal here. Don't make it too tough. Look at the next one. I used all this Leibniz notation for all these problems I just did. I don't have to give you Leibniz notation. I can use Newtonian notation. Take a look at this problem. Find the derivative of the function f of x is equal to the integral of e to the x to 2x of the cosine of t squared dt. And don't forget to label it. Because we're using Leibniz notation, I want to label this stuff. Excuse me, Newtonian notation. Label this stuff. Well, we're supposed to take derivative. So the derivative of f, and I can use Leibniz too, is the derivative, d dx, of the integral from e to x of 2x of the cosine of t squared dt. But we know that the derivative integral cancels, so you're going to basically get the cosine of 2x, and we're squaring it, literally just plug it in for t there. Chain rule times derivative of the inside, which will be 2, minus plug in bottom. The cosine of e to the x squared times derivative of the inside. What's derivative of e to the x? Times e to the x. Cleaning this up, you would get 2 cosine of 4x squared, because it just looks better, minus e to the x times the cosine of power to a power of multiply. That's going to actually be e to the 2x. That's how they would probably put it on a multiple choice kind of an answer. They'd clean it up. Power to a power, you multiply. E to the x squared is the same thing as e to the 2x. Does that make sense? Questions? Now, one other rule from this particular section is the average value. Now, to understand where the formula for the average value comes from, here's the deal. I'm going to show you guys. If I ask you, even though you don't have much grades right now, but Webwork and those pre-section quizzes are going to close out on you guys real soon, so don't procrastinate. Get your homework done, especially on the 22nd. Everything closes, and that's all she wrote for it. So, assume you had some grades. How do you average your grades? Average value of a function. The function is grades. How do you average value that stuff? Well, what you do, average value of function, is you're going to sum up all your grades, right? And divide by the number of grades that you have. I'm going to call n being the number of grades I have. This is, quote, the average value of a function. You add up the Function divided by the number of functions that you got mindset here. It's the average. Okay? But here's the deal. We know that delta x is equal to b minus a over n. So if I take this, delta x equals b minus a over n, and I solve for n, this would give me n is equal to, put it over here and divide, b minus a divided by delta x. So I can replace this n with b minus a divided by delta x. So this would be the sum of f of x over n, which is b minus a over delta x. But I don't like dividing by a fraction. When I divide by a fraction, I invert and multiply. I'm going to put the delta x in the back, but I'm going to put the b minus a in the front, but it's going to be on the bottom. So this would be 1 over b minus a times the sum of f of x dx. All I did was flip it up, and the b minus a is on the bottom. I just put him out front as a constant, 1 over b minus a. And the delta x flips up to the top, sum of f of x times delta x. Well, here comes my formula. This is 1 over b minus a. Applying integral calculus. Riemann sums turn in integration, and this is your direct substitution thing here. Summation is that elongated s. Here's my function, and the delta x turns into dx from a to b, and this is how the formula was derived. What the average value is going to give you, if you got a function that just waves all over the place, it's going to figure out on average what is the average y-coordinate. It goes up, it goes down, it may be in the middle somewhere. We're going to figure out what the average y-coordinate is. That is what the f average is all about, average value function. It's a formula, right? It's calculus 2, so memorize it. It's the 1 over b minus a times integral from a to b of f of x dx. It's the integral of your function from a to b times 1 over b minus a. It's a formula. So here we go. Here's the problem right here. Find the average value of the function f of x equals x squared minus 1 on the interval between 1 and 3. All right, average value is equal to 1 over b minus a times integral from a to b of f of x dx. I have the formula memorized. This will be 1 over 3 minus 1 times integral from 1 to 3 of x squared minus 1 dx. Cleaning that up, that's 1/2 times integral from 1 to 3 of x squared minus 1 dx. 1/2 is a constant, leave it out front. Now we're going to integrate. Integral of x squared is x cubed over 3 minus integral of 1 with respect to x is evaluated from 1 to 3. According to the fundamental theorem of calculus, you plug in top. This will be 1/2 times 3 cubed over 3 minus 3. Minus plug in bottom, 1/2 times 1 cubed over 3 minus 1. So this will be 1/2 times 3 cubed is 27. 27 divided by 3 is 9 minus 3. Minus 1/2 of 1 cubed is 1/3 minus 1. So this is 1/2 times 9 minus 3 is 6. Minus 1/2 times 1/3 minus 1 is negative 2/3. Here the 2's cancel. 2 goes into 6 3 times. So this is going to be 3 plus 1/3. So the answer is 3 1/3 for you people who just love mixed fractions. For the rest of us, it's 10/3. Take it either way there. So in other words, if I take my graphing calculator and clear out the old function there and graph this thing, this function was x squared minus 1. And all I care about is between 1 and 3. So I'm going to change my window from 1 to 3. And I'm going to graph that. And there it is, between 1 and 3. Okay? The average y-coordinate on this graph, because it does have a little curve to them, because it is a quadratic, the average y-coordinate is, I'm just going to put it in there so you can see it, it's going to be 10/3, 3 1/3. That point right there, that's the average of the y-coordinates, that level. That's what this thing is measuring. Webwork problems from this section. The section was short because it's an idea, and a very quick idea, but something you need to learn. So take a look at this Webwork, and we're going to put all this stuff together. It says this: let f of x be equal to this interesting piecewise function. 0, 2, 4 minus x, and negative 2. 0 if x is less than negative 5. 2 if negative 5 is less than or equal to x, which is less than 2. 4 minus x if 2 is less than or equal to x, which is less than 6. And negative 2 if x is greater than 6. So I just put this nice little grid up here. So I'm going to put the coordinate axis right about here. So here's my y-axis. And right in the middle, actually one level below, I'm going to put my y-axis right here. The x-axis, excuse me. Here's your x-axis, here's your y-axis. I decided to put my grid there because I want to graph this thing. So, here we go. 0 if x is less than negative 5. I'm going to graph this thing. Here's negative 1, here's negative 2, negative 3, negative 4, negative 5. Right here at negative 5, when x is less than negative 5, I'm actually got 0. So I'm kind of shading this little spot right there. Now, I get 2 between negative 5 and 2. Here's 1, 2. When equal to, so I'm going to put a dot, I'm going to get 2. So here's the level 2 right here. So right here I'm going to get a dot. All the way over to 2, it's going to be open circle, and y equals 2 is a horizontal line. So just graphing, well, this is just graphing the piecewise function of what it looks like. But here's the big one. Between 2 and 6, here's 2, 3, 4, 5, 6. Between 2 and 6, I get the line 4 minus x. When I plug in 2, 4 minus 2 is 2, so I actually hit the dot right there. And then when I plug in 6, 4 minus 6 is actually negative 2, and negative 2 would be down here, so I actually hit this point. When I plug in 4, it's 0, and it's going to be open circle right there. But going through this point, it's a line, so there it is, going down. And then when x is greater than 6, 7, 8, 9, I'm going to get negative 2. So it picks up that little dot and carries it the rest of the way. This is my piecewise function. They tell you this, that g of x equals the integral from between negative 5 and x of f of t dt. They gave me that. Now, I drew a picture, and we're talking about, and this is the function f of x, and we're talking about integrating it. And when I integrate a function, and especially when I got a picture, the mental comparison thing, the mental thing you should be thinking about is, quote, area under the curve. You've been programmed personally by me. When I integrate, it's area under the curve. So when they ask me, hey, what is g of negative 10? That would officially be the integral between negative 5 and negative 10 of this f of t dt. But when I think about this stuff, we're talking about area under the curve. The question is, how much over here, here's negative 10, who cares where it is, how much area is there under the curve between negative 10 and negative 5 if the curve is actually on the x-axis? The answer is 0. There is no area. I know the bounds are backwards, but I don't really care because the function is actually on the actual x-axis, and when you integrate, you're finally calculating the area between that curve back to the x-axis, but when you're on the x-axis, there's no area. The answer is 0. Now, we want to find g of negative 3. G of x is the integral between negative 5 and x of f of t dt. That will be the integral between negative 5 and negative 3 of f of t dt. Here's negative 5 right here. Here's negative 3. So if I just kind of throw this in there, the integral is the area under the curve. We got a box. Area of a box, being a rectangle, is length times width. So the width is 2, the height is 2. This is going to be 2 times 2, which is equal to 4. The answer to that guy's 4. Pay close attention to it because you know you got a Webwork problem that looks just like this. Numbers are different, but the idea is the same. Here we go. Next one you're supposed to do is g of 2. G of 2 would be the integral between negative 5 and 2 of f of t dt. Remember, you're starting at negative 5 here, but now we're going to go over to 2. Here's 2, so now we're talking about this area. So it has a length of how long? It's 5 to this point, and 2 more makes it 7. The height is 2, so this is going to be 7 times 2, makes the answer 14. Then they threw another one at you. What's g of 6? G of 6 would be the integral between -5 and 6 of f of t dt. So we're starting at -5, but this time we're going to go all the way over to 6. So here's the 4, 5, 6, and here's 6 down here. What do you notice? Well, the answer is going to be, what do you think the answer is? Hopefully you can look at it and tell what the answer is. 14. Why is the answer going to be 14? Outstanding. Because this region here is a triangle, length times width, so you got this idea of 14. This area right here, which is 2 by 2, and it's a triangle, so 1/2 2 by 2. Half of 2 by 2 is 2 itself. This one is also another 2 by 2, but so it's an area of 2 because it's a triangle. But this one is below the x-axis, it's negative. This one's above the x-axis, positive. So fishy, this would have been 14 plus 1/2 2 by 2 minus 1/2 2 by 2. This part ends up canceling. That's why the answer is 14. Your little triangles, one's positive, one's negative, because it's captured below the x-axis, cancels. So what is g of 8? That'll be the integral between -5 to 8 of f of t dt. 8 is located right here. So I've got how much? I've got this. So I'm going to kind of put this in pieces here. I got this long piece right here, which is 14, plus I got this little triangle right here, which is 1/2 2 by 2. I got this triangle right here, which is below the x-axis, which makes it negative 1/2 2 by 2. Plus, what's the last piece I have here? I got a little box right here. And it's 2 by 2, but it's located below the x-axis. It'll be minus 2 times 2. So the answer is going to be 14. That cancels. Minus 4. The answer is 10. We're playing area games with this stuff. Got a question for you. If part B here. G of x is increasing on the interval between what and what? Look at the values of G. G is the actual area. Where does the area start? Right here it's at 0, then automatically we started getting some area. Where did the area start at? -5, when x is -5. And we got area, more area, up here it's 14. We got some more area right here. And then once you got past 4, what happens? We got area, but it's now located below the x-axis, which means it's negative. We start taking away area. Does that make sense? So where is the area increasing at? From what point to what point, and where does it actually stop increasing area? At 4. This point right here. This is where the maximum amount of positive area is going to be at. Because once you pass 4, that's when your negative area shows up and it starts taking away. So now we've got a question. The absolute maximum of g of x occurs when x equals what? And what is the maximum value equal to? G of x is the area under the curve of f of x. Where does the maximum occur at? What x value? Where do we get the maximum area at? When x was what? X was 4. And how much area is it? When x is 4, you've got this big rectangle part of area, and you got one little triangle above the x-axis. This has an area of, 14. This has an area of 1/2 2 by 2, which is 2. 14 plus 2 is 16. The answer is 16. Does that make sense? It is that integral between -5 up to 4 of f of t dt. Here's another Webwork problem. It asks you, find the average value of the function f of x equals 25 minus x squared on the interval between 0 and 4. Average value is a formula. The hardest part about average value is there's other ways in English you can describe average value. Find the mean of the function. Mean, M-E-A-N, and average means the same thing. Statistical terminology here. Mean and average are the same thing. If they say find the mean value of the function, it means the same thing as find the average value of the function. And it's a formula. So watch the language in terms of average value. But this one, we threw it in your face. Average value is a formula. It's equal to 1 over b minus a times integral from a to b of f of x dx. This would be 1 over 4 minus 0 times integral from 0 to 4 of the function 25 minus x squared dx. So this is 1/4. Integral of 25 with respect to x is 25x minus integral of x squared is x cubed over 3, evaluated from 0 to 4. According to the fundamental theorem of calculus, plug in top minus plug in bottom, this is going to be 1/4 of 25 times 4 minus 4 cubed over 3 minus 1/4 times plug in bottom. Plugging in bottom for x would be 0. Plug in top minus plug in bottom. Love plugging in 0, kind of goes away there. So this will be 100 minus 4 cubed is what? 64 thirds. So you end up getting, for you calculator fans, 19.66667, or for us engineering fans out there that love fractions, 59 thirds. We'll take it either way. It's just a calculator problem now. Does that make sense? Keyword is average value. It's basically a formula here. But there's a part B to this problem. Part B of this problem says this. Find the value C in the interval between 0 and 4 such that f of C is equal to this average value. Well, f of x was equal to 25 minus x to the 4th. F of C, just to use their notation, would be 25 minus c squared, and it's supposed to be equal to this average value of 59 thirds. I just said it equal to 59 thirds. Your mission in life now is to solve for C. So how would I solve this thing for C? I would subtract 25 from both sides. This gives me negative c squared equals, and I'm going to put it on the calculator so you guys can see this, 59 thirds minus 25. And I'm going to just make it a fraction out here. That gives me negative 16 thirds. What's my next move in terms of algebra? I'm going to divide by -1. Right? Get rid of the negative first. So this gives me c squared equals negative divided by negative is positive 16 thirds. And now what's my last move? Square root of both sides. Now officially I'm supposed to take plus or minus the square root, but because the interval is between 0 and 4, which square root do I want? For the c is supposed to be in this number. It's got to be the positive square root. So c equals 4 divided by the square root of 3, and we don't care if we rationalize or not. Question? Yeah. What did I get x to the 4th from? I don't have a clue of where I got x to the 4th. That's supposed to be squared. And then I plugged it in. There's my c squared. I don't know. I saw a 4 up here someplace, and I must have copied it down. Thank you. 25 minus x squared, and when I plug in c, it's 25 minus c squared, so I'm back on the right track again, equals my average value of 59 thirds, and then I'm using the algebra to solve for c. 4 over square root of 3. Thank you. Does that make sense, though? Questions? All right, number 11 is another one of these problems that we want to kind of throw some stuff at you guys. How do I integrate a piecewise function? This guy here. F of x equals x if x is less than 1, and f of x equals 1 over x if x is greater than or equal to 1. How do you integrate an absolute value? Well, we're supposed to evaluate the integral between -4 and 6 of f of x dx. So the integral between -4 and 6 of f of x dx. But remember, with integration, you can break up the bounds. The point that breaks this particular piecewise function, the breaking point is the point 1. Does that make sense? So I'm going to rewrite my integral as this. This will be the integral between -4 and 1 of f of x dx plus the integral between 1 and 6 of f of x dx. I can break up any integral I want because we're talking about integrating this entire function f of x. It's the area from -4 to 6. Well, that would be the same thing as the area from -4 to 1 plus area from 1 to 6, just breaking the pieces apart. But I did this because of this. Now we've defined this particular function. This would be the integral between -4 and 1. That means the x's that we're plugging in are between -4 and 1. And when we're less than 1, and when we're less than 1, we actually have a particular function that we can plug in. What's this piecewise function when we're less than 1? The function is x dx. Plus, when I integrate from 1 to 6, that means we're bigger than 1. And when we're bigger than 1, the function is 1 over x dx. Now, I can actually integrate an actual function, so you have to break it apart so you can put the piece of the piecewise function into your integral. Integral of x is x squared over 2, evaluated from -4 to 1, plus the integral of 1 over x, that's a special rule. What's that? Natural log absolute value of x, evaluated from 1 to 6. So according to the fundamental theorem of calculus, plug in top minus plug in bottom, this will be 1 squared over 2 minus -4 squared over 2 plus fundamental theorem of calculus on the second part, natural log of 6 minus the natural log of 1. Natural log of 1 is 0, things we know from junior high school or high school or whatever. This guy here, this is equal to 1 squared is 1 half minus -4 squared is what? 16 halves plus natural log of 6. And 1 half minus 16 halves is, that'd be natural log of 6 minus 15 halves, makes the answer look better. There's my answer. Now, look at part B. We have a piecewise function on this guy. It says, evaluate the average value of the function. The average value is equal to 1 over b minus a times integral from a to b of f of x dx. That'll be 1 over 6 minus -4 of the integral between -4 and 6 of f of x dx. This 6 minus -4 is what, 10? But here's the deal. What is the integral of my function between -4 and 6? We just did that in part A. We had to piece it apart, use the piecewise function of each piece, integrate each piece, evaluate each piece, and add the answer together. There's the integral right there. So it'll be 1/10 times, so I actually don't have to do any work here, the natural log of 6 minus 15 halves, and it doesn't get better than that, so there's your answer. How you evaluate, integrate a piecewise function. Okay? Well, we have one more problem to do on this section, but of course these 50-minute classes, I get going good and then all of a sudden we're out of time. So I will do this problem next time for you guys on test, and then we're going to start section 5.5. 5.5 is very important. This is now we're beginning to get more techniques of integration. Right now, all you got is 14 formulas you got to have memorized. This is how we're going to expand it. A very important concept called use substitution. All other integration is based upon this. We'll do this next time. See you guys then.